US Physics Olympiad, year 2016, USAPHO. Final round. This round consists of two consecutive parts. Part A, which had 4 problems, and part B with 2 problems. For each part they were given 60 minutes, and the solutions for all these problems you can find in the reference of the description below this video. Problem A1. The Doppler effect for a source moving relative to a stationary observer is described by formula F equal F0 over 1 minus V over C cosine theta, where F is the frequency measured by the observer, F0 is the frequency emitted by the source, V is the speed of the source, C is the wave speed, and theta is the angle between the source velocity and the line between the source and observer. Thus theta equals 0 when the source is moving directly toward the observer, and theta equals pi when moving directly away. Sound source of a constant frequency travels at a constant velocity past an observer, and the observed frequency is plotted as a function of time. The experiment happens in room temperature R, so that the speed of sound is C equal 340 meters per second. Question A. What is the speed of the source? Question B. What is the smallest distance between the source and the observer? Solution for problem A1. Question A. If we look at this graph, we can see that on this picture for time equal 0, we have almost 0 degrees theta. And for time 14 seconds, it's almost 90 degrees. So we can write two equations. For these two asymptotes, we have F1 equal 449 Hz and F2 equal 422.5 Hz. So now we can divide first expression by second expression and find what is V over C. So from here we can find that V over C equal approximately 0.0310, and the speed of the source equal 0.6 meters per second. That was the answer for question A. Question B. Also we can find what is the frequency of source. That will be F1 multiplied by 1 minus V over C, or around 435 Hz. Question B. What is the smallest distance between the source and the observer? Let's take first derivative from this expression. dF over dt will be this expression, and in point when theta equal pi over 2, we have this expression. In point theta equal pi over 2, we have dF over dt equal negative F0 multiplied by V over C and multiplied by V over d0, where V0 that's a shortest distance for theta equal pi over 2. And from here we can find what is d0. We just need to measure what is the slope of this graph in point for theta equal pi over 2. Finally, for shortest distance, we have this expression, and dF over dt we can find from graph in a region where F0 equal 435 Hz, and this will be our approximate answer, 20.5 meters. This is the answer for question B, and this is solution for problem A1.